Hello everybody and welcome to section 7.1, geometric mean, and we're also going to talk about altitudes of right triangles. Geometric mean between two numbers is the positive square root of their product. For two positive numbers a and b, the geometric mean is the positive number where the proportion a to x equals x to b is true. This proportion can be written using fractions. A over x equals x over b, and cross products yield x squared equals ab, or x is the square root of ab. Basically, geometric mean of two numbers, you multiply them and you take the square root. That's what this is saying down here. Okay. Up next, Theorem 7.1, if the altitude is drawn from the vertex of the right angle of a right triangle to its hypotenuse, then the two triangles formed are similar to the given triangle and to each other. So we're going to have three triangles formed here, the big one, smaller green one, smaller blue one. And this theorem says that all three triangles are similar, and therefore their sides are proportional to each other. Here's a visual of what's going on. The big triangle, little triangle, and the smallest triangle. These are all similar. They're all proportional to each other. Theorem 7.2, the measure of an altitude drawn from the vertex of the right angle of a right triangle to its hypotenuse is the geometric mean between the measures of the two segments of the hypotenuse. Okay, so in this picture here, the YW altitude can be found by taking the geometric mean of this XW segment and WZ segment. See how that works here in this example. Find YW if XW is 14 and WZ is 4. Okay, so here we have XW 14, the smaller yellow segment here, WZ is 4. Now here's the proportion showing what's going on. 14 over X, our unknown YW segment, is the same as X over 4. Cross multiplying gives x squared equal to 56. The square root of 56 is 7.48, would round to 7.5. Basically, we just found the geometric mean between 14 and 4. Okay, let's see this in another example. Here we have the same situation. This time our numbers are 12 and 3. XW is 12, WZ is 3. If we found the geometric mean between 12 and 3, which is 36, and take the square root, the value of YW, the altitude is simply 6. Here's another example. It's a little bit different. XW is 15, but they give the entire distance XZ this time, 21. We don't know our needed distance here, WZ. It can be found simply by taking the 21 minus the 15, and gives us 6, and we see that right here. Again, geometric mean between 15 and 6. This is not 15 times 6 is 90. Square root of 90, 9.49, or 9.5. Let's look at another theorem here. The altitude is drawn from the vertex of the right angle of a right triangle to its hypotenuse, and the measure of a leg of the triangle is the geometric mean between the measures of the hypotenuse and the segment of the hypotenuse adjacent to that leg. Now I know that's rather wordy, but if you just remember that all the triangles formed by that altitude are similar, we can set up a proportion and solve. Here's an example. Find xy if xz is 10 and xw is 7. Okay, our xz distance is the whole hypotenuse of the big triangle. Our xw distance is just 7. Okay, and given these proportions, we'll just plug in our values, and our unknown value we're trying to find is xy. That's the long leg of the right triangle. 10 over x equals x over 7. X squared equals 70. Square root of 70 is 8.37, also 8.4. Again, here it's just the geometric mean of the 10 and 7 distance. Just one more example. Find zy. Zy is the shorter leg of the big triangle. The proportion xz over yz is the same as zy over wz. And just as setting up proportional parts, corresponding parts, proportional triangles, we have 22 over x equal to x over 6, x being the distance zy that we don't know over here. Then we just need to find we crisscross multiply to get our geometric mean. X squared equals 132, and the square root of 132 is 11.49.